Hi, everyone. I'm Doug Black at Inside HPC, and today we have with us Vasu Agrawal. He is research engineer at Meta and a user of Liquid's composable computing software platform, specifically the UltraStack architecture with Dell PowerEdge servers that can have up to 20 NVIDIA GPUs. Vasu, welcome.
Thank you. It's a pleasure to be here.
Okay, tell us a little bit about the project that you're working on at Meta and give us an idea of the computing requirements and demands.
Absolutely. I work on codec avatars broadly. We are trying to build photorealistic telepresence effectively. So, over the past few years, people may have seen some of the work that we've published in having super photorealistic humans that are indistinguishable from reality, is the term we like to use around here. We want to make it so when you put on the VR headset, you feel as though you're transported to another place. Like I could be in your office having this conversation instead of over a VC like we're doing right now. And so specifically to make that happen, it takes a lot of compute. All of our approaches are based on machine learning, and that's notoriously compute expensive. And so the project that we're doing specifically with this UltraStack hardware is really trying to bring to bear the power of modern GPUs and composing as many of them as possible to bring the experience from something that we can see in 2D on a desktop in cinematic frame rates, as I like to call it, 24 or less FPS, to something you can actually run in VR, you can feel immersed. So really, that's the crux of it, is trying to get the experiences that we've been developing in a more researchy stage to one step closer to visualizing them in a headset in VR and seeing really can we buy the experience? Can we believe the photorealism?
Okay, tell us about the challenges you were facing, some of the shortcomings of your previous computing resource for this project, and how it sort of got in the way of the goals you're
Yeah,
seeking.
absolutely. So I'll go into a little more detail on the project first. So for this photorealistic experience, right, we want to have avatars and we want to have environments. And so specifically, my team is focusing on the environments part of it. And 2 years ago, roughly, when we were starting this project, really kickstarting our environments effort, that the the most impressive technology out there at the time was NeRF, neural radiance fields, and they're very, very photorealistic. The problem is they're very compute intensive, and so we even on a single GPU, it takes seconds per frame, if not more. There's some approaches that made it a little bit faster, but still not VR rates. And so we started with just a couple of GPUs, and that's sort of the first approach was just we bought an off-the-shelf box from a company where you could plug in one HBA to a PC. You could plug in a couple of GPUs to a tiny box, 3 or 4 GPUs maybe, and that gives you some expansion. You can have a few more GPUs in your PC, but it's still not. And you can parallelize it across that, but it's only a little bit better. And so the shortcoming was we just weren't getting fast enough. Even with the compute intensity of NeRF based methods, we weren't able to hit the speeds that we were looking for, the 72 FPS target at full resolution for 2i buffers. Trying to do that, we just weren't able to get the speed. So the approach we were targeting was, can we get to higher frame rates by adding more and more GPUs? And so we were looking around for various options. We looked at doing just more of those boxes. So instead of having one box with 4 GPUs, we looked at having a couple of those. We looked at having slightly bigger boxes that were just like 8 or 16 GPUs. But none of those really met the stability or the performance criteria that we were looking for, because you also, once you introduce multiple GPUs, you need to worry about GPU to GPU communication as well. And so eventually, through a long chain of events deriving from a collaboration that Liquid did with Linus Tech Tips a few years ago, I stumbled upon Liquid's latest offering, which was their what was now called the UltraStack, then called something else. And reached out to them. We got a trial unit in, and then met a lot of the performance needs and performance criteria that we were looking for. And so we pursued some more work with them and made it collaborated and made it work for our application.
So tell us a little bit about Liquid UltraStack and how it meets your requirements.
Absolutely. The stack that we're using, I think, is a bit unorthodox. So Liquid intends for their solution, I believe, to be used to compose GPUs across multiple PCs. That is, the intent is you have servers, depending on the workload that you're doing on a, say, cluster machine. One server might need 1 GPU, one server might need 10, and then later that those needs might switch or they might balance out more over time. That's not what we have. We just want as many GPUs as possible on a single machine. So when the first version of this system that we built, affectionately known as the Turtle, we built with 20 GPUs in two different liquid chassis, 10 slot enclosures each, and then connected those to one server. And that works, and we don't use any of the composability. We just compose it once and it's done. We, of course, take advantage of the fact that in doing the composability, Liquid has to have all the traffic go through a PCIe switch, or a chain of them actually. And that means that all the GPUs can communicate with each other very efficiently without having to go through the CPU. So we still take advantage of the hardware performance characteristics that we get, that the composable solution also gives us. We just don't take advantage of the composability. However, we recently built a version 2 of the Turtle, and what we learned, which is largely the same, but one of the things that we just newer GPUs primarily, and what we learned was the failure, the likelihood of failure of having a single machine is not great. So in the second rack, what we actually did was we put two almost identical machines, with the first one being a little bit more powerful for just as a plan A, effectively. And then the composability, which we've tested and it's fantastic, lets us dynamically switch GPUs between the two machines. Both are running Windows, by the way, which is notorious for not necessarily supporting this PCI hotplug super well. But whatever either Microsoft is doing, whatever Liquid is doing, even on our Windows 10 servers, which, yes, Windows 10, not Windows Server, even on our Windows 10 servers, the composability worked great. You can hot plug the GPUs, you can take 19 of them out, you can take 20 of them out. Windows just does the right thing, and then, or the entire stack rather, just does the right thing. You can move them around. So on our second rack, maybe to summarize, we've been able to use the composability to just have a fallback plan, which is really great when you've got only one of these machines that you're bringing with you, or one of these racks rather, that you're bringing with you to a demo, and you're showing it to hundreds of people at a conference or to a VIP or something. You really want the reliability that you get from having a backup plan, which the composability makes it super easy for us to do.
Vasu, can you give us one or two on the performance end of things, one or two before and after comparisons on UltraStack performance, some aspect of your workload where you saw marked performance improvements?
Yeah, absolutely. We published a paper not too long ago at SIGGRAPH Asia in December. And in that paper, we have a chart showing some of the performance characteristics across a number of GPUs for our approach. I can look at the numbers here, actually. The short version is that we get somewhere between, we go from, at one GPU, looks like we're at about 18 FPS for one specific example, and we get up to about 100 or so. So 5 to 6x improvement, which is not the linear scaling that you want with 20 GPUs, but it is substantially better, and that is enough for us to get to the performance in VR frame rates. And so we're able to see the full experience that we want at VR resolution, at VR frame rates. So while the scaling itself is not the linear scaling that you want necessarily, it's still decent, I think. And more importantly, it takes something that was not previously possible into something that is now actively possible and used, and it that is the value for it of it for us. It is now, things that were previously impossible can now be seen in real time, which is, that delta is more important than the actual scaling, I think.
Yeah, on the GPU lead time issue, how long did it take for installation and access to UltraStack with NVIDIA L40S GPUs?
Yeah, absolutely. So like I said, we've built two different units of this. We have our first unit, which uses the A40s, and for VR specifically, we needed a GPU that has a display output on it. And so we were looking at the time between A40 and A100, and we found that for our specific rendering workloads, machine learning and rendering workloads, the A100 performance wasn't really that different from the A40. Certainly, I think that value prop changes if you're doing more other types of models, but for our specific use case, the A40 actually competes with or outperforms the A100, and so that's what we selected for the first unit. And of course, we needed at least one of those anyway because it had a display output, which we needed to be able to run to output to a headset. When we go to V2, we were looking at either doing the A40, the L40, or the A100. And it just so happened, sort of fortuitously, that right when we were about to pull the trigger on making a decision on what GPUs we were going going with NVIDIA announces the L40S. And so we were able to work with Liquid and say, hey, these things are more power hungry. They go from 300 to 350 watts. Can you handle it? Can our cooling stack handle it? But Liquid was very accommodating and validated the new hardware as soon as it came out, basically for us, and tested and make sure that that we weren't going to have power issues. We weren't going to have cooling issues. So we were able to upgrade to the new L40S. And yeah, the performance has been substantially improved over the A40. I don't have exact numbers, but I think it's pretty close to the paper specs of the delta that you might delta that you might expect, given the specs on paper, rather. But yeah, the availability from the L40S has been really good. I think we were supposed to get the first shipment or a part of the first shipment from NVIDIA through our distributor. We ended up not getting that, but I think the second shipment came out a month later. So it wasn't a huge setback compared to what I've heard are like 6 months plus lead times for A100 at the time. And now H100 especially is even worse, I think. So the availability has been really good for us.
Okay. Well, thanks so much, Vasu. We've been with Vasu Agrawal of Meta. Thanks so much for your time.